Okay, so you are welcome to today's lesson. This is Neco 2022 examination. So we are solving the paper 2. Okay, so let's look at question number 1. Question number 1. So in question number 1, you can see the SI unit of pressure is, say, A, Newton meter, Newton per meter. You can see the options there: B, Newton per meter; C, Newton per meter cube; D, Newton meter A, Newton meter square. Okay, now, what is pressure? What is pressure? So, pressure is defined as what? So, what is pressure? Pressure is defined as force per unit area. Pressure is defined as force per unit area. So pressure is equals to force over area. And what is the unit for force? Newton. What is the unit of area? Meter square. So you can actually write it like Newton meter per square, or Newton per meter square. So our answer is B. So B, option B is the correct answer. Okay, option B is the correct answer. So this option B is the correct answer. So we have number 2 question here. Number 2 says, which type of motion is exhibited by a turning fork on a hard object? So you can see our answer here is oscillation. Oscillation, because a turning fork, because it vibrates back and forth when struck. Yeah, a turning fork vibrates back and forth when struck. When you hit a turning fork, it will vibrate front and back. And you know, oscillation is the to and fro movement of a body. Okay, so the answer is A, oscillation. So here in number 3, they said calculate the time in minutes that it will take a car traveling at 120 km per hour to cover a distance of 20 km. Okay, that's very simple. So let's calculate. Remember, the formula for speed is what? Distance over time. But we are looking for time. They asked us to calculate the time. So we make time a subject of the formula. So in that case, it will be time equals to distance over speed. Distance over speed. So this is our new formula because we're looking for time. So cross multiply, make time the subject of formula. So our new formula is now time equals to distance over speed. So what's our speed and what's our distance? So in the question here, we are asked to calculate the time in minutes. Remember, in minutes, so we must convert hours to minutes. Okay, all right. So calculate the time in minutes that it will take a car traveling at 120 km per hour to cover a distance of 20 kilometers. So our distance is 20 kilometers. So we come here and write 20 kilometers. Okay, 20 over, what was our speed? Our speed there is 120 km per hour. So 120 km per hour. So 20 divided by 120. Okay, so this is our calculator. So let's go. 20 divided by 120. So equals to 0.166. So our time is equals to 0.166 hour. Okay, or approximately 167 hours Remember, kilometer cancel kilometer, this cancel this. Okay, so remaining hours. So convert these hours to minutes, and converting hours to minutes, you times by 60. So times by 60, so we say 0.166 or 0.167 approximately. So our answer equals to times 60. So we have 10. So our time is equals to what? 10 minutes. Our time is equals to 10 minutes. Okay, so our answer is C, 10 minutes. C. Okay, so let's go to question number 4. Question number 4, the velocity time graph shown below represent the motion of a car. So here you can see the velocity time graph. They said the magnitude of the retardation of the car is what? Retardation. So here's the retardation. Retardation means falling down. So we look at here. So looking here, you can see that BD is it will be BD over DC. BD over DC for the retardation. You make use of what you have here. That's number here, and make use of your time here to find the retardation. So you can see D is the answer. Okay, D is our what answer. So let's go to number 7. Question number 5. It said a man traveling 5 km north, then 7 km east. Calculate his displacement from the starting point. Calculate the displacement from his starting point. So to solve this question, you should know your 4 cardinal points. So we have draw your 4 cardinal points. So you have your east, you have your west, you have your north, you have your south. So they said a man traveled 5 km north. So from here, starting here, 5 km north, then 7 km east. So 5 km north, 7 km east. So you just draw your line here. Okay, 5 km north, 7 km east. So here should be your theta. They say we should calculate his displacement from the starting point. So to calculate the displacement from the starting point, you need to calculate the distance and then the distance. So to calculate this, you need your Pythagoras theorem. Okay, so let's do this. With your Pythagoras theorem, remember northeast. So let's call here H, or you can use any letter of your choice. Okay, or you can still use your northeast, any which way. Okay, we can just use a letter. So call here H, maybe call here A, call here B. Okay, so let's go. So we have H square equals to A square plus B square. So H square equals to 5 km square plus 7 square. So H square equals to 5 times 5 25, 7 times 7 should give you 49 if I'm not mistaken. Let's check our calculator. So 7 times 7, yeah, 49. So we are right. Okay, so 25 plus 49. So 25 plus 49 plus 25 should give us a 74. Okay, so we have H square equals to 74, right? And square crossing over the equal to side, we change to square root. So H equals to square root of 74. So square root of 74 is what? Let's check. Square root of square root of 74 is 8.6. So h equals to 8.6. So we are not done yet. This is the distance, so we need the direction. We need to calculate the direction, and to get the direction, okay, so to get the direction, we need to use our soccer tool. So looking at our diagram here, you have opposite over adjacent, so which is tan. Remember the soccer tool, for so you have opposite over hypotenuse, car you have adjacent over hypotenuse, and the tan you have opposite over adjacent. So since this is opposite over adjacent, we are using the tan, so our tan theta equals to opposite over adjacent. And what is our opposite here is 7 km, so 7 over adjacent, which is 5. Okay, so tan theta 7 divided by 5, so we use our calculator here. So 7 divided by 5, we have 1.4. We have 1.4. So tan theta equals to 1.4. So tan crossing over the equal to sign, we change to tan inverse. So we have theta equals to tan inverse of 1.4. So let's check our calculator to see the tan inverse of 1.4. So press your shift. I know most of you knows how to use your scientific calculator. So tan inverse of 1.4 is 54.46. So approximately should be our theta should be 54.5. So generally we have our distance and our direction. Remember, our distance is 8.6, so not our distance is 8.6, so 8.6 kilometer, then the direction should be 54.5 northeast. So let's check the option. 8.6 54.5. So our option should be C. This as an option. So let's look at number 6. Number 6 says a body moving with a velocity u accelerates uniformly for t to cover a distance s. This acceleration expressed in terms of the given variable. So what is the acceleration? So we are looking for the acceleration. So the formula for the acceleration, we quickly use our kinematic equation, which is s equals to ut plus half at squared. So kinematic equation, which is s equals to ut plus half at squared. Okay, so we make a, which is acceleration, the subject of the formula, and to do it we multiply everything with 2. So 2 times s equals to 2 times ut, okay, plus 2 times half at squared. Okay, so 2 times s equals to 2s, 2 times ut equals to 2ut. Now look at here now, 2 times half at squared. This is multiplication, so 2 cancel 2. 1 times 1. So this has cancelled out, so we are left with plus at squared. Okay, we are left with plus at squared. So to eliminate 2ut. To eliminate 2ut, we minus both sides by 2ut. So we say 2s minus 2ut equals to 2ut minus 2ut plus 8t squared. So we're not going to minus 2ut from 8t squared because t squared contains the variable we're looking for, which is a. So we're going to minus 2ut from 2ut and 2s. Okay, so 2ut minus 2ut gives you 0, so it cancels out. So we have 2s minus 2ut equals to 8t squared. So in that case, we divide both sides by we divide both sides by t squared. We are dividing both sides by t squared because we want to eliminate t squared so that a can be alone. Okay, so that a can be alone. So divide by t squared, divide by t squared. So t squared divided by t squared. So you are left with 2s minus 2ut over t squared equals to a. Remember, so rewriting, you have a equals to 2s minus 2ut over t squared. Okay, so this can also be written as a equals to 2 brackets s minus ut over t squared. The same thing, because 2 times s give you 2 s, 2 times ut give you 2 ut. So so do you have our answer here? Yes, E is our answer. So that's what they have here. So we have question number 7. A body of mass 0.3 kg is suspended by a string to which a horizontal force of 5.0 Newton is applied to make an angle of 60 degrees as shown below. Calculate the tension T in the string if it is in equilibrium. So you are giving G, which is acceleration, as 10 meters per second square. Okay, so looking at this drawing, the vertical force is cos 60, which is equals to mg, mass times acceleration, while the horizontal force is t sine 60. So let's solve. So the vertical force is our t cos 60, which is equal to mass times acceleration mg over our horizontal force. So horizontal force, which is equals to t sine 60, which is equals to 5.0 Newton. So our tension now, which is T, is equals to mg over cos 60. Our mass in the equation is 0.3, and our acceleration is 10, divided by our cos 60 is 0.5. Here, cos 60. When you press cos 60, you get 0.5. Okay, so you get 0.5. So 0.3 times 10. Okay, let's use our calculator. 0.3 times 10 equals to 3. 3 divided by 0.5. So our answer divided by 0.5, and we are having 6. So 6 is our answer. Yeah, in this we have the 5.8. If you approximate 5.8 to give you 6, so D is our answer. D is our answer. You can see 5.8 approximate to give you 6, so D is our answer. So looking at question number 8, An example of an object in a state of stable equilibrium is A or an. This is very simple. Here we have a ball on a flat surface. A ball on a flat surface is not stable. If you shift it a little, it will not return to its original state. Remember, a stable equilibrium is an object that when displaced, it will still return to its original state. So, but when you move a ball, it will continue moving. It can never return. Okay, let's jump B. Let's go to C. See, we have cone resting on its vertex. So you move it, it will not return. We have D, which is cylinder resting on its slide. A cylinder resting on its slide, when you move it, it will continue moving. Egg in a bowl, when you move it, it will move. But look at B, benzene burner on its base. A benzene burner on its base stands firm. When you move it, it will still stand, it will still return to its shape. So the answer is B. Okay, so we have number 9. A stone is projected horizontally from the top of a cliff with a velocity of 12 meters per second. If it reaches the ground 2 seconds later, calculate the height of the cliff. You are given an acceleration to be 10. So you solve. Our formula is half gt square. Okay, you have your half gt square. Okay, so equals to half times the gravity is 10 times your time is 2 raised to the power 2. So 2 times 2 4. So you have 1 equals to half times 10 times 4. Okay, so 10 times 4 gives you 40. So you have half times 40. Half times 40, 1 times 40, 40, 40. 40 divided by 2 gives you 20. So our answer is 20. Do you have it? Yeah. So 20, which is C, is our answer. C is our answer. Okay, C 20. As you can see, 20. Okay, so in number 10, we saw the angular velocity of a body changes uniformly from 250 rad to 400 rad in 20 seconds. Calculate the magnitude of its angular acceleration. So to calculate the angular acceleration, calculating this, so we have alpha equals to wf minus wi over t, which is time. So we have it as 400 minus 250. Our time is 20 seconds. So simply do equals to 400 minus 250 over 20. So let's punch our calculator to see what we have. So 400 minus 250 equals to 150. So divided by 20, we have 7.5. So our answer is equals to 7.5 ras. So A is our answer. A is our answer, 7.5. Number 11. So we have here a man weighing 80 kg climbed up a flight of stairs to a height of 30 meters in 10 seconds. Calculate the power he expended. You are giving gravity or acceleration, or gravity to acceleration as 10 meters per second square. We know it's constant. So we have our options here. So let's solve. We are looking for power. What is the formula for power? The formula for power here is P equals to work over time. So what is work? Our work can also be mass times acceleration times height. And we have our time. So here, let's get our mass, let's get our acceleration, let's get our height. So here you can see that our mass says 80. Okay. Acceleration here is 10. Sorry, our mass here is 80, our acceleration is 10, yes, and our height is what? 30 meters. So 80 times 10 times 30 over time, which is 10 seconds. So let's punch our calculator here. So let's go 80 times 10 times 30. So that will be equals to 24,000. So 24,000 divided by 10. Okay, so that will be 2,400. So 2,400 watts. 2,400 watts. 2,400 watts. So our answer is C. So I see. Okay, looking at question number 12 here. So we have this question here. An inclined plane with velocity ratio 2 has an efficiency of 70%. Calculate the force required to push a load of 140 Newton up the plane. So the force means effort. We are asked to look for effort. Okay, so here our effort is load over what? Over mechanical advantage. Yes, load over mechanical advantage. Here we have our load to be 140 Newton. So we have 140 Newton over mechanical advantage, but we don't know our mechanical advantage. We don't know it. So we are going to look for a mechanical advantage. So looking for mechanical advantage, we go with the formula efficiency. Efficiency equals to mechanical advantage over velocity ratio. Okay, so making mechanical advantage subject of formula, we have mechanical advantage equals to efficiency times velocity ratio. So our efficiency is what? Efficiency is 70%, which is 0.7. 70 divided by 100 give you 0.7, and our velocity ratio here is 2. So we have 0.7 times 2. So 0.7 times 2, using our calculator, 0.7 times 2 gives you 1.4. So our mechanical advantage is what? Our mechanical advantage is 1.4. Okay, so we're placing this in the formula here. So our load 140 over 1.4. Remember, we're looking for effort. So 140 divided by 1.4 should give us what we want. So 140 divided by 1.4 should give us what did it give us? 100. So our effort is 100. Yeah, answer is B. 100 Newton, please. 100 Newton, yeah. Answer is B. Okay, so that's it.